So, what's the like unique difference when you are trying to
Exactly.
differentiate between the
So
two?
we will go through the difference, Karamo. We'll first see a little bit of background about Docker. Then we will, build our way from there.
All right.
I'm just making the machines ready. So, all right. So let's get started with Docker. So obviously, the first thing comes, as you said, right? It's like people say that it is like Vagrant. Um, Vagrant helps you create virtual machines, right? And if you have worked with VMware, you will find this picture familiar, right? You have the physical machines, the physical hardware, like your RAM, CPU, and this can be your laptop hardware, as well as it can be a server hardware in your companies, right? And on top of that hardware, you install a hypervisor, and hypervisor examples can be a VMware ESXi server, or it can be a Hyper-V server, or a Linux KVM server, or let's say Citrix Zen server. So you have a number of options. VMware and Hyper-V are probably the most popular ones to be um, there in the market, right? So
So,
the hierarchy, yeah, tell me.
I mean, if you say hypervisual, do you mean like virtual machines or like virtual box or no? It's like a
Yes,
service.
VirtualBox is also an example of a hypervisor.
Mm.
However, in hypervisor, if we go into virtualization technologies, actually we have two types of hypervisors. We call them as type 1 and type 2. Okay. So type 1, actually, you don't need to have an OS installed, right? There, you can actually directly install the hypervisors on top of a physical machine, on top of a hardware. Whereas in type 2, you need to have an OS installed. So in our case, if you see our example, you have a Mac machine. On top of Mac, you have installed VirtualBox. I have a Windows machine. I have installed on top of Windows this VirtualBox. So I have the hardware, then the OS, then the hypervisor, right? So that is what we are using. VirtualBox is a type 2 hypervisor. If you take the VMware example, VMware uh, ESXi is type 1 hypervisor, and a VMware Workstation, or if you're using Mac, then VMware Fusion is your type 2 hypervisor. Is that clear?
Yeah,
Okay.
it is.
So this is a typical example of how it happens in your enterprise environments. You have physical machines, and there are servers. It can be mainframe, Dell, HP, any of those servers. On top of those servers, you have a hypervisor installed. It can be ESXi from VMware or KVM or Zen, as I said. There are multiple providers. VMware and Hyper-V are probably the two most popular ones, respectively from VMware and Microsoft. So you install the hypervisor. On top of that, you create virtual machines, right? You will have typically in a enterprise environment on a single host. We call that hypervisor a host. Each physical machine is a single host, and virtual machines which you create, they are known as guests, right? So typically you have anything above 10, like 10, 15, 20 virtual machines you have, right? And each virtual machine is independent of each other, right? You create the virtual machine, and then you install an OS on top of that as well, which again can be a Mac, a Windows, a Linux, Solaris, AIX, anything, right? It is independent of the underlying hardware. You can install any of those supported uh, uh, operating systems on that OS, right? On top of those virtual machines. Once you have the OS installed, then finally you install any of these apps which you need to work with, right? And the app can be anything. It can be a database, it can be a web server, it can be an application server, right? It can be a networking device. It can be anything you can install. Any of these apps you can work with once you have the virtual machine ready with the operating system, right? So this is the typical example of a virtual machine architecture, which we have seen so far, which we are already familiar with. Okay. Now, this the second one on your right hand side is an example of a container architecture, right? Now, if you see differences, what happens? You have a physical machine. On top of it, you install an operating system. It can be a Windows, it can be a Linux. Typically, it is Linux because so far the container technology, this Docker technology, was supported only for Linux machines. Okay, so you have typically a Linux operating system. On top of
But
that operating system,
sorry, I have downloaded Docker. I didn't even know what it was really, but then it was compatible with Mac. I wanted to learn a bit about it because I've seen it
right?
somewhere.
Okay,
So is it compatible with Mac or no?
your voice is not clear, Karama. I'm sorry. Could you please speak a bit louder?
I think it's compatible with Mac operating system.
I'll tell you what exactly happens. Then you understand. Just keep it for the time being. Just start your question. I'll tell
Okay.
you what happens in case of Mac and Windows. You have boot to Docker, the package which you have installed.
Okay.
Just
I've downloaded it straight off the website, and then I click on it to install
yeah,
it.
just check it out.
I've never touched
Probably
it.
is this software. It will say like this: boot to Docker. This will be the name of the
Okay.
package which you might have installed. This is available for Mac and Windows.
Okay.
I'll tell you what is the difference. When I say that it is only compatible with Linux, what exactly I mean by that, I'll tell you. Just keep it.
Okay. Okay. Okay.
Okay. So what happens is you have a Linux operating system, and on top of that you have containers. Now we have actually two things. In case of a virtual machine architecture, on the left hand side, what you have is essentially is it's a hardware level virtualization, right? What is happening is if you virtualize your, if you install a hypervisor, essentially what it does is it divides your hardware into multiple virtual machines. So although you have a single CPU, you have suppose 120 or 130 GB or whatever capacity of the RAM, and you have a storage space. This thing is actually divided into 5, 10, 15, 20, whatever number you mention, whatever number of VMs you create, it is divided among them, right? So each machine thinks that it has got a set of processor, it has got a set of memory, and it has got a set of this storage and all these underlying devices, right? It has got NIC cards and all those things. So essentially, it virtualizes your hardware so that it thinks that each of these has its own set of hardware. Each machine, each virtual machine, things like that. Whereas in case of a container, if you look at the left hand side, sorry, right hand side, what happens is the operating system is actually divided into multiple parts, and each container, if you see the container, this thinks that it has got its own operating system. It does not bother what kind of physical machine it has got. Okay, so this one for a virtual machine, it's a hardware level virtualization, and for a container, it's a operating system virtualization. Okay, so this is some of the key things which you need to keep in mind. This is one of the key differences between virtual machine and a container technology. People might ask you this. So virtual machine essentially is a hardware level virtualization, typical hypervisor what we talk about, and container is a operating system level virtualization. In virtual machines, the hardware is divided into multiple parts to give a feel that you have multiple hardwares. In case of a container, the operating system, and essentially when we say OS, we are talking basically about the kernel. So the kernel is divided into multiple parts and gives you a feeling that you have multiple, isolated operating system environments, right? So that is a first fundamental difference between virtual machines and containers. Now, why containers? Why this technology, right? If you see on a screen, if you go back to the previous one, we have at this level, we have virtual machines divided, and then we have, for each virtual machine, we have a separate operating system installed, right? In here, we have a single operating system installed, and on top of that, we have multiple containers. Now, if we do some mathematics, what happens is containers consume less CPU, RAM, and disk resources than virtual machine. How it happens? If you see here at the bottom, a single operating system instance needs 10 GB of disk space, 4 GB of RAM, and 5% of CPU. This is kind of averaged out figure. It's not exactly a hard and fast rule, but this has been seen as an average when you create virtual machines on any of the hypervisors, typically VMware. Okay, so what happens is each OS requires this much of space only to run the operating system, not the applications, only for the application. Now, if take an example that on a single host you have 10 virtual machines, so obviously you will have 10 different OSs. And if you multiply this figure with 10, you have 100 GB of disk space, 40 GB of RAM, and 50% of CPU is utilized only for your operating system, not for your application. Okay, so this much, about this much space and RAM and CPU is saved, because essentially what is happening in this case, instead of 10 different OSs, you have a single OS, right? So all that CPU, memory, and RAM is, this is spaces saved for you, right? You don't need multiple OS instances. You can directly work with the applications, right? Which is more important. Why we run servers? What is the idea behind running this servers, right? We are not bothered about how OS is happening, how OS is performing, how networking tools are performing. Essentially, we are creating the infrastructure to run our applications. That is the highest priority, right? So that is what we bother about. So this is why we use containers. The prime requirement or prime reason for using containers or shifting towards containers is because of optimal utilization. Okay. Now let's see another term. It's something known as when software development practice started, about, like, it was quite old, but till 2000, it has started changing a couple of things. If you see, in fact, I would suggest you, once you complete this course, today, tomorrow, whenever you get time next, you search this term on Google and read what it gives you. Monolithic versus services, microservices. Monolithic versus microservices. What has happened is, let me explain to you. What has happened is, early 2000, till early 2000, what happened? If you talk about a software, it was a single big unit of software which was being used, which had all the components built inside of it. Okay, so from outside, it was a very big chunk of keys which had all the functionality inside it. Okay, and it needed big servers like mainframes typically to run those applications. Okay, so a lot of the components were inside that software, inside that particular monolithic. That was known as monolithic architecture. But gradually what happened, people started shifting, the software development started shifting towards microservices architecture, wherein we had a lot of small components, small independent components talking to each other in the form of API calls. And what happened? Since they were independent, if you wanted to make some change, you can just remove that component and bring in a new one. So the changes were rapid, and changes were easy to work with, easy to implement. Services were loosely coupled. When we say loosely coupled, that you can actually, take out one piece of it and put another piece inside instead of that one, just like a puzzle. Okay, so what happened was the more flexibility and more rapid development started happening, right? And even from the hardware point of view, hardware perspective, we did not need the big servers anymore. What you could do is you can run a huge number, instead of running one big giant mainframe, you could run 10 or 20 or 30 small servers with very 1/10 of the cost. You can run all these servers. So again, the advantage was if something goes wrong, you can just remove that server from the hardware piece and you can bring in another one with a very minimal cost. Rather than if something goes wrong with the mainframe, you just have to replace the whole unit, which was quite expensive, right? So this is very important actually to understand, because in DevOps we keep on working with this model. We keep on trying to implement the microservices architecture, right? So this is a very crucial thing, which is very important to understand.
Sherry,
Yeah.
can you give us like a scenario in the real working environment, how you use Docker?
Docker, I'll give you scenarios.
And what you
We'll
do
work with
with it?
Docker. We will work with a couple of things, but again, giving microservices example will be difficult. I will give you all the concepts because what happens is, in case of DevOps, as a DevOps engineer, you will help them. You will help the developers to create the Docker containers. Okay, but the microservices architecture and microservices enabling microservices architecture will be the job of a developer. It can be a Java developer, it can be a .NET developer. That will not be your job. Okay, you will help them. I'm sorry, implement those things inside the containers from the DevOps point of view. Okay, because what will happen whenever somebody moves from monolithic to microservices architecture, what essentially happens is they rewrite their code how it is happening. Okay, so that is not your job, so need not worry of that part. What you need to worry, or what you need to understand more is, suppose they tell you that they want 5 containers, and 5 containers will run. Out of 5, one will run the DB service, one will run the network service, one will have this process on the Docker, and one will have that process. So that is when you work with the developer and help them create that environment. Okay, so first understand the concept. I'll give you as much scenarios as possible. Okay, but just concentrate on the concepts as of now. Okay, so if you see in the diagram, this is a very good representation of how it happens. The left hand side you can see monolithic, and on the right hand side you have microservices architecture. So monolithic, as you can see, it's a very big giant piece of code, where if you want to change something, you have to make a changes at a lot of places inside. Okay, wherein in microservices you can just remove, since they have given the container picture actually. So what you can do is you can just go ahead and remove any of the containers and put another one in that place, in its place, and it will work just fine. Okay, as long as you have the dependency and the API is called correct, right? So this is something which you just need to go through. Uh, Monolithic architecture versus microservice architecture. What are the kind of fundamental differences? And if you see architecture, first one, monolithic architecture represents a single logical program unit. All functions, libraries, dependencies are located within one application block. Okay, so you have all these things, all these libraries and dependencies, and all these functions. They are inside that monolithic architecture. If you want to change something, you have to make the changes at all of these places, right? Whereas in microservices architecture, it consists of a series of small services that work independently. That is the keyword here. Okay, and communicate with each other. And when we say communicate, it works. Most of the things, it works in the form of APIs. Okay, and yes, other important point is each service can be used in more than one application. So same container, if you can put the same container into other applications as well. So now we have the concept of reusability, like we do in object-oriented programming, the modular approach, right? So same thing you can apply here in container technology as well. So scalability, yes, and the entire application scales horizontal behind the load balancers. What happens is scalability is an issue here. You just can't go ahead and increase and decrease just like that. You will have repercussions, and you need to understand before you can do that. Whereas in microservices, you can kind of say you have 10 containers, out of which 2 or 3 containers are for DB, and suppose your DB has high load, then you can add another DB container to take that load off, right? So that is how it is scalable in case of microservice architecture. Agility, as I said, if you need to make any kind of changes, you need to make sure that changes are taken across along the system, and anything you have to make changes at all the places wherever the dependencies are there. Whereas in microservices, each service can be changed independently, right? Yes, this is one of the very important differences. When you do development, it is typically in a single programming language, right? So if you see here, what happens is, since it is a monolithic, you will have a single programming language across the board, right, for the whole software. So you will have, if it is .NET, it will be .NET for the whole of project. If it is Java, it will be Java for the whole of the project, right? Whereas in microservices, what happens? Each container is a kind of self-contained entity. Okay, so if you go by the example in the picture over here, all the green containers can be a .NET. The blue one can have all the Python. The orange ones can have all the written instructions written in Ruby, and so on. Since all these containers can have the functionalities written in different languages. So that's the flexibility microservices architecture. Okay, so and yes, maintenance wise, very long and confusing source code. So this one, Monolith, again, once again, going back to the picture, Monolith will have, once the code is written, it goes on like that, right? Unless something, people don't tend to change things unless needed, unless something goes wrong. And if something goes wrong, then it is a real mess to make changes. You don't know what happened and what went wrong at which place, right? Unless you are the same person who has written the software. And even if you are the same person, if you have written the software 10 years back and something goes wrong after 10 years, you might not find it to be very easy to replace it, or to rectify the problem. Whereas in microservices, since it is all independent, it's a lot of small pieces written together, so you can actually pinpoint exactly which piece went wrong, and you can just replace it with the right piece of code, and you can remove the bugs very easily here. Right? So what is Docker, right? Docker is an open source project that automates the deployment of applications by providing an additional layer of abstraction and automation of operating system level virtualization on Linux. Uh, Again, Docker is a client-server application where both the daemon and client can run on the same system, or you can connect a Docker client with the remote. We will see what exactly we're talking about here. What happens is this client similar we saw in Chef, if you remember. We had Chef Server and Chef Nodes, and we had Chef Workstation. We don't have any such workstation here, but we still have this master-slave concept. Okay, and host or the server here is the Docker daemon, which is typically run on one machine. All the other containers you can create on the same Docker machine, same Docker host, or you can utilize the resources of a separate machine, and you can have a Docker daemon at a separate place. So you can think of Docker as very lightweight virtualized environments. Okay, this is what you can think of as of now. As we work along with more with it, you will understand more about it. So yeah, instead of virtualizing hardware, containers rest on top of a single Linux instance. This allows Docker to leave behind a lot of load associated with a full hardware hypervisor. So if you remember, we saw this example, right, wherein we spoke about the comparison, and since it has a single OS instead of 9 or 10 different OSs, a lot of additional resources which were required as per this diagram, as per this mathematical formula, all those things are gone. You don't need all these 100 GB of disk space and 40 GB of RAM. 50% of your CPU space, CPU utilization is, all these things are not needed at all. Okay. And yeah, so yeah, this is what I was talking about. Don't mistake the Docker engine as the equivalent of a hypervisor in a more traditional VM, right? Container technology and virtual machine technology, these two are two completely different things. Okay, there is no relation in between.
Wow.
So now the question is, hasn't this already been done? Yes. A lot of us, we think that container is a new technology. Docker is right, like, from the last 2 or 3 years, it is there. Uh, Docker is new. Docker is not exactly very old, but the container technology, that is actually very old. If you go and check, you might find about this. If you see this LXC, LXC stands for Linux containers. Okay, and we had this technology from quite some time. If I am not wrong, IBM had used it. This IBM is using this technology from 1970s. Okay, so this technology is already 30, 40 years old. Okay, what Docker has done, Docker has made this process highly, easy to manage. Earlier, you had to do a lot of things in order to create a Linux container which had isolated environments to work with. But in case of Docker, it's just a matter of couple of minutes to configure. And when you want to create the machine, it's just tell me one thing, guys. When you created a Vagrant machine, how long it took for you guys? It took to bring the machine up.
About 5 minutes. About 2, 3, 4, 5 minutes, depending on the packages it's downloading or the size of the Vagrant machine.
Right. So let's say you had you are using a virtual box, I mean a Vagrant box, which is already downloaded. If it is not downloaded, then obviously depending on your internet speed, it might take up to 10 minutes also. But once it
Yeah,
is downloaded, still it needed 2 to 3 minutes, if I'm correct, right? Once
definitely. Yeah.
you write Vagrant up on your machine, it needed easily some 2 to 3 minutes for the machine to bring it up, right? Now, in Docker, that time is actually 2 to 3 seconds.
Very nice.
We tell Docker run and then we give the machine name. It takes around 2 to 3 seconds to bring up the machine.
Wow.
Okay. So we'll see that. So the important point, what I want to convey is that Docker is new, but the container technology is old. Okay. And we have, if you see the names on the screen, FreeBSD, Sun Solaris, Zones. From Google, you have IMCTFI, OpenVZ, LXC. All these are the technology which are there for quite some time. What happens is Docker has made it surprisingly easy, and many times easier. They have made it, and that is why it has suddenly become very popular. Okay, so next point. Now we need to understand the Docker components. Okay, we'll deep dive into Docker one by one. Let me just, in fact, and yeah, once again, guys, what I have done is I have not gone into the installation part here because installation is again pretty simple in case of Docker. You just need to use yum install Docker and it will install the Docker on your machine. Or in case of Ubuntu, it will be apt-get install Docker. Apt-get install Docker. You need to do. Okay. I have a document. I'll send it to you guys. You can just check it out. And let's just focus on the Docker components here. You check it out and work with it. Try to install it. If you face any problem, just let me know. I'll help you out with that. Okay. So we have a couple of components in Docker. Understand them one by one. Okay. First one is your Docker engine. This you can think of same as your chef server. This is the core of your Docker. Okay. This contains and it stores a lot of information. This is the store for your containers. Okay. And Docker engine is also known as Docker daemon or simply runtime. Okay. The main job of Docker is to manage containers using jobs. So what happens is, guys, what happens if you have, let's say, take an example of Docker daemon. Okay, so you have and you have some 3 or 4 containers running. Just like
your voice is going.
So, yeah, what I was telling is, you have a Docker daemon and you have 3 or 4 containers, just like in Vagrant, you had uh, uh, Vagrant, a lot of, 3 to 4 Vagrant machines running on a single host, right? What happens to Docker daemon? For the Docker daemon, each container is a process. It's actually a job, just like a job in Unix. Like you have a job in Windows, right? A single process or a single this thing. Similarly, in for Docker daemon, it's a single job for to be run or to be maintained. Okay, but for container inside, it thinks itself as a full-blown virtual machine. Okay, it doesn't understand that it's a container. So yeah, that is one thing. And the Docker engine needs to be installed on all Docker hosts.
So how big can a Docker container be?
What do you mean by how big? You mean the
Like
size?
the storage size, yeah.
It depends. It can be anything. That depends on your. Just like in virtual machines, it is not dependent on virtual machine, right? You can have a 1 TB, 2 TB hard disk attached to the virtual machine. It depends on your storage capacity. So similarly, in container technology also, it can be anything. It depends on your host capacity, not on the containers. Okay.
All right.
So that is one thing. First one was Docker engine. Then we have Docker images. Now, if you remember, when we worked with Vagrant, we had this Vagrant boxes, right? Can you just tell me what exactly Vagrant boxes were?
Vagrant boxes contain the Vagrant file and the
No,
Vagrant machine, no?
no.
Uh, Vagrant box is like a its own independent operating system.
Vagrant boxes were like the templates, right? From where you had to clone the images,
Oh yeah.
right? Do you agree with me?
Can you explain that further? Because I think the Vagrant boxes, they are the one that contains the machine. Like they contain each both Vagrant boxes.
Contains the machines, you have the machines locally available, but Vagrant boxes, let me show you. So I had this one, right? Vagrant box list, if I give. It is, what are these? Okay. And
Your voice break.
yeah, so what I'm telling is these are boxes, right? Which currently I have on my laptop. So if I want to use a Ubuntu machine, if I want to create an Ubuntu machine, I need to give this box name as my base box. If I want to use a CentOS machine, I need to give this name as my base box. So what will happen? The new machine which is being created in Vagrant, it will clone from this particular box, right? And if you guys have worked with VMware, we have a concept of cloning from templates. The templates are nothing but the standardized images of the virtual machines. So you can clone from the virtual machines, right?
Yeah, but you use the Vagrant file to clone, to put the operating system in the base where the base in code is.
Yes, when
Is
you
that
say
what?
base will not take. You have to change base with any of these names, right?
Yes.
And when you change the name, what exactly happens?
It then clones the
Clones
exact.
from this
Yeah.
machine.
Yes.
And if this machine is not present on your laptop, it will first download that machine from Vagrant Cloud or Vagrant app, right?
Yeah.
So basically, these are the standardized. These are the golden templates that are there on Vagrant Cloud. From Vagrant Cloud, you download it on your local machine. You keep it as box images, and any machine which you are creating from the it will clone from this, right? But these are not the actual machines. These are the images from where you are cloning.
Audio.
Can't hear.
So, your voice is getting disconnected. lot of. Okay, can you hear me, guys?
Yes, loud and clear.
Yeah, it's nice now.
Okay. So yeah, that's what I was telling. So you have a concept of boxes, you have a concept of machines, and machines, Vagrant machines are getting copied or getting cloned from the images or from the boxes, right? Any confusion?
Yes, it's clear. Mm-hmm.
Okay. So similarly, what you have boxes in Vagrant or templates in virtual machine in Vagrant, sorry, in VMware. Similarly, you have a concept of images in Docker. Docker images, as you can see the first point, it's like a templates in VMware. So you already have all these things available. Similar way, the way you have Vagrant boxes, you have this Docker images. You make use of these images and create your own containers from these images. Okay, we'll see how we create and all those things. We'll see that in just a bit. First, let's understand this portion here, right? And important point here is Docker images. They are layered. They work on a layered technology. We'll see that what exactly layers, what we mean by layers, and we'll look at that. Okay, so if you see here in the previous example, this picture is actually a Ubuntu image. Okay, so this is an Ubuntu Docker image which is available for anyone to be used from Docker Cloud. Okay, and if you come here, what happens? The next step is the Docker container. So similarly, how we created Vagrant machines from Vagrant boxes. Similarly, from Docker images, we create Docker containers. Okay, so the images are the templates from where we clone our actual machines, and containers are the actual machines which we are creating and which we are working with. All right, and if you see the example, this is the Ubuntu image, and from this image we can create multiple containers. So as it has been created in here. Okay. And if you see here, each container is a fully sandboxed runtime execution environment for our applications. What do we mean by that is that each container has got all the necessary details for a operating system. It is independent of each other. When we say sandboxed, we mean that it is isolated. Okay, it is isolated from other containers. So whatever you do with the first container, if you make any changes, if you change any of those things, it will not affect container 2. Okay, whatever you do, it keeps inside this container only. It does not go and it does not cascade to container 2. That is the main advantage and one of the most important advantages of using container. Okay, so second point is that containers are launched from images. It is a bare boned Linux machine. What we mean by that is that what happens in the Docker and Vagrant, if you work with these kind of technologies, what happens? We try to make them lightweight, right? So in order to make it lightweight, what we do is we remove all the unnecessary packages before we create a template, a box, or an image out of it. Okay. So in Docker, in fact, you make it so lightweight that even some of the basic commands will not work here. And in actual world, when you will start working with Docker, you will see that you don't have a lot of standard commands like SSH, like telnet, like ifconfig. Even these commands are missing from the Docker images. If you want to use that, you need to include those commands. You need to run yum docker, yum install let's say yum install telnet or yum install SSHD or any of those such commands in order to for those commands to be available inside your containers. Okay. Next point is one process per container. That is known as practice inside Docker. What it means is when you work with this microservices architecture, if I go back, this one, right? As a best practice, suppose you have an application and the application comprises of 10 or 12 or 15 different processes or jobs. Okay. So what as a best practice you do is that you each container will have only one process. Okay, it will not have more than one process. Okay, we'll see. That's more like a best practice, nothing to be worried about in terms of technicalities. We'll see how we work with the containers. Now, the major difference between a container and an image is the top writable layer. All writes to the container that add new or modify existing data are stored in this writable layer. Okay, so when a container is deleted, the writable layer is also deleted. The underlying image remains unchanged. What we mean by that is you have this Ubuntu base image, right, from which you are actually creating containers. So when you create a container, what it does is it just creates an additional layer on top of your machines. Let me see if I have an example here. It's not there. So I'll show you later on. I'll show you from Google if I can do it. So what happens is you create an additional layer when you all these layers below. If you see on the screen, you have 1, 2, 3, 4 different layers. All these are read-only layers, and they help you create the base OS. Okay, but you can't write them, you can't edit them. So when you create a container, a layer on top of that is additionally created, which is actually your container layer on which you actually write your and make your changes. Okay, so that is about Docker container. This is the life cycle of a container. This is again a diagram which will help you understand. Nothing complicated. Don't bother too much about this diagram now, because point is very simple. We create a container, we run the container, then we can pause it, we can stop it, we can kill it, just like a virtual machine you create in a Vagrant. Once you create the machine, you can keep the machine running, you can stop the machine, you can pause the machine, you can halt it, right? You can halt it, you can suspend it, then you can resume it, then you can destroy it. Similar kind of life cycle of a container is shown here for Docker. Okay. Next important component is your Docker Hub. Okay. Docker Hub is exactly same as your Vagrant Up. We had this atlas.vagrant.com, right, from where we downloaded the images and the boxes of Vagrant. Similarly, you have Docker Hub, from where you actually go ahead and download the images. Let me show you a small example. Right, so this is the place. This is the main Docker website. I encourage you to create your Docker Hub ID. It's nothing just like signing up for an email. It's just a one-time task, and you can have an ID and a password for yourself, and you can work with it. Very simple to make this. Then explore. And if you remember, similar thing we had done in Vagrant, you have this repositories, right? So let's say we go to this Ubuntu repository. Okay, let's click on this one. This is Ubuntu image for Docker. And just like you had in Vagrant, in here you also get the command. You can just type in Docker full Ubuntu, and it will download this Ubuntu repository or Ubuntu image for you. Okay. So this is how you check it out, and you can get all the information over here. What exactly this is about, what are the changes, what are the things it has done. Right? You can just read more about it over here. So this is the Docker pull command. This helps you, just like in Vagrant, you had Vagrant box add command, right? You give Vagrant box add and the command the box name. It will download that box for you on the machine. Similarly, if you do a Docker pull Ubuntu, it will download Docker this Ubuntu system for you. Let's see if I have Docker running. Let me see if I can show you. I hope my Docker machine is working. So yeah, this is the command. This is how you work with Docker Hub. Once you have an account, you can work with the Hub directly and building and sharing your container. What happens is you can see the registry, right? So what we call it, this is known as the Docker registry. You have all the images is saved on the cloud, which you can download as per your wish, right? So I think yes, Docker is running for us, and let's run some commands. So let's see our first command, how it works, what exactly happens. Right? We will run, let's say, let's just run this docker run -i-e CentOS in bash. Now, what it is going to do? Let's run this command and let's meanwhile understand this also. In my case, what has happened is it has actually immediately come inside the machine. If you see here, it's already inside the machine. And if I do a uname -a, it will give me this. And if I do a host name, it will give me this name, right? So this one is the host name for Docker. Unless you specify, it will give this alphanumeric figure automatically to the any of the host machines which you create, any of the containers rather, right? So what happens is, if you give this command as we gave on our lab, it will first pull the image. In our case, the image is already present on the machine, so that is why it did not download. It directly created. Then it creates a new container. It allocates a file system and mounts a read-write layer, right? So as we told, right, we spoke in one of the previous slides that what happens is the image layers, they are not editable. They are kind of fixed, I'm sorry, read-only layers. On top of those layers, when you create a container, a thin read-write layer is added for your changes to take place, right? So that's what happens in this step. This automatically creates all these read-write layers, then allocates a network bridge interface. A networking setup is created, sets up an IP address, of course, and executes a process that will specify. Let me see how we can specify the process directly. Captures and provides application output. So basically, what happens is it gives you all. Let's see this one. What you can do is actually how you work with Docker. I mean, it will be a little bit difficult for you guys to understand now because it's difficult to show you a use case. But how it happens is Docker container, you don't keep it running like a virtual machine. Okay. That is one big difference between Docker and virtual machine technology. When you create a Docker container, you create this container for a specific purpose. Now, if you remember, I spoke that as a best practice, what happens? Docker container maps one-on-one with process, one process per container. That's the golden rule of Docker, right? So what happens? Typically, you define a process, right? This is what needs to be run on the Docker container. So how you create is the workflow. How it happens is Docker container created, processes run. All these in this previous slide, if you see, all these things take place. The mount and the read-write layer is created, networking is created, sets an IP address. Then it executes that process which you specify. Okay, and it captures and provides application output. And if then it comes out also. Okay, so you come over here. Let's see another example here. So what we will do. I actually did a control plus P plus Q to come out of the virtual machine, to come out of the container. Okay. Let's just show you this another one. So Docker run -d Ubuntu bash. -c stands for you when you give a command to be run, right? So it will run the command h.8.8 -c 30 times. So basically, it will run that command 30 times inside the container. Yeah. So now if you run this, what will happen? It will pull the Ubuntu image if it is not there. It will create that new container from Ubuntu image. It will ping the DNS server, this server which we have mentioned 8888 30 times as per the command given, and then the container will exit also. So come here, run this. It pinged 30 times the machine and it came out. Right. So just show you. Docker info is the command. Let's just check a couple of commands here. So when you give Docker full, let's say Docker images, this will give you the images currently already downloaded. This is same as you give a Vagrant box list. Okay, it's the same command how you give in Vagrant. Then you have Docker info. This gives you the information about your Docker host. What are the things you have available on that Docker machine? If you see here, yeah, over here we have total 30 containers, and we have 75 images, which is quite a lot, right? So, and then what kind of pool size you have, all these supporting information, right? So how much data space you have total, how much you have used, how much available, all those things information you will get. Okay, and what you can do is actually then you have Docker attach. So Docker attach, once again, what happens is just give me a sec, guys. Just give me a moment. Okay, I'm sorry. All right, so we have this Docker info. Then let's say Docker PS is the command. Docker PS actually tells you the current images, whatever is in running condition. So if you remember, we had one image is created, which actually, we came out of it, right? And you can see it here. Now, let's say you want to go inside this container once again. So what you do is you just need to do Docker attach. Oh, sorry, not this one. Rather, you can actually click here. If you do this, it will take you inside that machine.
Terry,
Yeah,
what does this attach do? Does it attach the machine to the container or?
to the container. Yes, yes.
um,
See, in case of Vagrant, you go inside the machine using SSH command, right? Vagrant SSH you do.
Yes.
In Docker, when the instance is already running, when the container is already running, and you want to attach to that container, then you use Docker attach. So it will take you to that container. I don't know why it's not happening. Slow. Okay, it's there actually. You see, they're already inside the container. what is happening here is actually the machine is not getting refreshed. Actually, I mean the screen. You see here, it's coming back. Actually, it's inside the container, so that is why it's not getting clear. However, if I do, it's still not happening. If I do an exit, so now if I do a docker ps, if you see, there is no image running. So what happens? There is a small thing which you need to understand. When you go inside a Docker machine, okay, and when you attach the machine, you are working with it. In case of Vagrant, what used to happen, if you come out of machine, the machine will still be running, right, just like a virtual machine. But in case of Docker containers, since as I told you that it works on a methodology that machine container created, process ran, container shut down. So what happens if you do an exit from the Docker machine? It will actually shut down the machine also. It will stop the machine automatically. Okay, so that is why if you want to actually create, if you want to come out of the machine without killing it, then you need to run this command, control this. Okay, this is what you need to run. And yeah, this is all the standard commands: docker attach, docker stop, docker restart. So same as Vagrant, you have all these commands. You can create machines and you can delete machines. Docker rm, if you use, well, actually the same as Vagrant destroy. Okay, so docker stop is same as Vagrant halt. The docker rm is same as Vagrant destroy. So you can delete the container if you want to do it from here. And just like that, all these informations. Docker run will actually run those. So we saw that run option, right? So this one, if you run, it will create a container, right? So if you want to do, just you need to run one more container if you want to run. Yeah, so just do that, and you're inside the container automatically, right? So what we need to do, let's just control P and Q, guys. If you do, you will come out of the container. And now if you do a docker ps, it will give you the running container information. Now let's say you want to see all the containers which have been killed as well. So docker ps -a, I think, if I'm not wrong. Yes, correct. So this will give you all the information, right? And due to some reason unknown to me, what happens is whenever you create a Docker container, it gives a funny name automatically. It assigns a funny name to the container. So all these containers, right? So if you see here, this name belongs to this particular container. Okay. Right? So if you see,
really funny.
Yeah, it's very funny, man. I mean, I don't know how it happens.
Cookie Wilson.
Yeah. You have all these funny names associated with each one. So when you are actually working with a Docker container, let's say you want to kill a container. So docker stop, or let's say docker rm, you can give either this name or this name. Any of these is fine. Okay, it will work on both. So let's say docker stop container ID. Okay, so this is how the basic operation of Docker, how it takes place. Then yeah, this is one important thing. Just like Docker file. Okay, I have given an example of Docker file. I just want to explain to you. You can. It will be more like a homework for you guys.
Voice, no voice coming.
Okay, so what I was telling is, instead of Docker run command, what we can do is actually we can create a Docker file, and we can you know, bring up or spin up containers from there also. Okay. Again, the concept is very simple. It's not exactly very complicated. What happens is you have this file created. So what you can do is when you have certain keywords. Okay. So from, if you give, you need to give the image name. So Ubuntu, you can give the version also 14.04, CentOS, or anything, whatever you want to give, that you can do. Give it. Then when you want to install something, so you can give all those things here only. Okay, so run will run those commands on the container before it comes into, before it installs. It's like giving provisioning a script to the Docker machine, Docker container which you will be creating. Okay, so when you want to add those things, then you can run these commands as well. npm install. Right. env actually creates the environment. So env port 3001 will actually expose this port. Okay, this will open, and then if you do expose, it will expose this port, right? Then cmd, you can actually go ahead and run these commands. So these are some of the things which you can do with Dockerfile. And Docker run is kind of lab environment, which gives you the capability to check something on the fly. But when you work in enterprise environment, when you are creating the Docker containers, working with microservices, then actually you're working with Dockerfile. Okay, this is how you are creating the containers. Okay, I'll give you a very basic example. This is kind of since Docker is a huge topic, it actually it's a very big topic. I just wanted to give you a brief introduction and the important things in Docker, right? So these one are the building blocks which we spoke about. This one: Docker engine, Docker images, Docker containers, and Docker hub. Okay, so these are the important concepts which you need to understand. Install, once you are familiar with this, what I would suggest is you install Docker. I'll send you a document, or you can just type on Google how to install Docker, whichever machine you are installing for, like Ubuntu or SUSE or Red Hat, anyone. Just type that, you will get a lot of information on Google how to install. It's just 1 or 2 lines to do. That's all. Okay. Once you install it, just work with, create some machines, create some containers, and work with that, and you should be good to go.
Sherry?
Yeah.
So it won't be possible to do this on the Mac, is it?
Yeah, good question. You reminded me that, right? We were talking that how it is not.
You told me about difference.
Yeah. Now you understand the Docker ecosystem, right? How exactly Docker works and this.
Yeah.
See, I told you that Docker is not there; it's there only for Linux, right? Actually, Microsoft has just announced there is something called Docker Beta, which has come up for Mac and Windows, but it was not there by default. What you would have installed was actually boot to Docker. Idea was very simple. You had see in our case when we installed, we
do they work the same or
boot to Docker? This one. So they have if you have boot to Docker, if you have Mac, if you have a Docker Beta for Mac, then you have actual Docker for Mac. See, what happens is Docker, what it does is it actually virtualizes the kernel. It divides the actual Linux kernel into multiple pieces, and it gives container. Okay, that is what it does essentially. So what happens in case of normal Docker architecture? You have this hardware. On top of that, you install, let's say you installed a Red Hat machine. Okay, Red Hat OS you install rather. Okay, then you install Docker engine, which is nothing but Docker daemon or Docker runtime, as we just worked. And once you have Docker engine installed, then you can create containers on top of it. Right? You have any confusion with this hierarchy? This is clear to you guys?
pardon?
This is clear, right? This diagram which I just created, this is clear to you guys?
Yes, it's
okay. Now, when you install, when you want to have this on your Mac or on your Windows, you have an option to install actually. But what happens is, you have a hardware. On your hardware, let's say you have Mac. Okay. When you install on Mac, when you install boot to Docker, okay, what it does is it installs a virtual box image. First, it installs a virtual box. On that virtual box, it creates a Linux virtual machine.
That
Which is a
would
Red Hat
run
machine.
the Linux kernel.
Sorry?
It builds you a virtual machine to be able to do work with Docker.
Yes. So now if you see in the diagram, you have a Linux virtual machine, which can be a Red Hat or a Ubuntu machine. On top, then you have a Docker engine installed, and then you have containers on top of it. Now you tell me, looking at the diagram, are we dividing Linux kernel or are we dividing the Mac or Windows? The same thing goes with Windows also. Instead of Mac, you will have Windows here. That's all. Okay. So all these additional steps, if you remove these ones till here, now is it on Windows, Mac, or is it on Linux? You tell me.
It's on Linux, definitely, because the VMware is between the Docker engine and the boot to dock virtual box.
Yes.
And the Mac,
that is why I was telling you that it's not there for Mac and Windows for this reason. You actually have it in the form of boot to Docker, but essentially, if you look at the architecture of that, you will find it's again a Linux virtual machine, right? So it's essentially Linux. It's not Mac, right? But yes,
definitely.
What
yes.
they have done last 2 months back, actually in October 2016, Microsoft actually announced that they will have for Windows Server 2016, they will have native Docker capability. So what it essentially means was that now they have Docker for Windows servers. So essentially Windows Server kernel is actually getting divided now into containers to create Docker engine is getting installed on Windows now. So now they have the actual capability of Docker on Windows and Mac. But till 4 or 5 months back, it was not there. And this one again, guys, this is still in beta stage, right? Still not for production or still not in actual licensed version. Okay, but it will be very soon because Docker is growing like anything. It is growing every single day, and earlier it was only for development and testing purpose. Now Docker is actually being used in production environment as well. Okay, there were security issues, there were scalability issues, like how we will manage so many these what do you call it, containers, just like virtual machines. So now we have, what happens is what we have seen so far is actually example of a single container, how to work with single containers. In Docker, that actually does not happen in case of corporate environments. What happens actually is you work with clusters, and these are essentially Docker container clusters. And you have in VMware, you are aware of vCenter, right? You guys know what vCenter is used for in VMware?
What is that again?
vCenter.
No, I have never heard about vCenter.
Oh, okay. In VMware, you don't work with individual virtual machines. You have a vCenter. It's a program, it's a software which actually gives you capability to manage the whole data center. With the help of vCenter environment, you can actually manage your data center. You can manage your machines, virtual machines. You can manage your SANs. You can manage your networking, switches. All these things you can manage with the help of vCenter suite. That's what we call it.
So,
yeah.
How do you manage this kind of things like networking and switches on VMware? Where do you actually go? Sorry, on.
That will make you a little bit familiar with that. So, yeah, are some of the very good examples. If you see, I don't have vCenter installed over here, and so it will be difficult, but I can show you these images.
Thank you.
Yeah. So if you see here, now it is clear, right? So all these individual hosts, these are the hardware. If you see here, these are the clusters. So each cluster has got hardware machines. So these are, suppose if you have 3 or 4 mainframe machines or Dell servers or HP servers, this denotes each of those servers over here, this particular diagram. These ones, if you see HW or whatever, D01, 02, 03, this is the virtual machines. Okay. Similarly, this is another cluster. You have 2 hosts here and only 1 virtual machine at the moment. Then you have another cluster, 1 host, and these many virtual machines. These are, if you see here, VM NIC1, NIC0, NIC3, NIC2. These are the networking cards which has been assigned. Okay, these are typically, this one is actually your distributed switches. We have switches. These are different VLANs. So again, I mean, this is, we are going too much into detail, but still, if you see here, at this level, if you see hardware, we are on the networking tab at the moment. Similarly, you have a storage tab, memory tab, processors tab. So this is the typical vCenter screen, and through which you actually manage your data center. So this one is a typical example of a small data center. It's not exactly very big data center. It's got only almost 7 hardware servers, mainframes or Dell servers or HP servers, and you have probably 10, 15 virtual machines. So this is an example of a very small data center, but this can go very complex as well. I think if you see in one of those diagrams, not this one. So these are all the small, what do you call it, data centers having, in this case, if you see, I have 3, 2, overall 15 or 20 hosts we have, right? And again, you can see options of managing processors, memory, networking, network adapters, all these things you can manage through vCenter. Okay, if I come here, okay, if I show you this diagram, yeah, this is a more clear one. So if you see here, we have selected this host. This is the host, this is the hardware on which you have all these virtual machines. Okay, and if you see here, you have all these with this green arrow that are the virtual machines which are currently running, which are not shut down. And the machines which is blue one, the first one, the second one, these are actually virtual machines, but these are shut down machines. These are not running at the moment. Okay, and this screen, if you see, it gives you a very good snapshot of total space, used space, how much memory is being used, right? How much CPU is being utilized, all those things. Right? So this is a typical vCenter screen which you have, which you use for to manage the data, right? So what I wanted to tell you is that similarly, the way you have vCenter to manage the VMware machines, you have a lot of Docker utilities. Okay, Docker gives you multiple utilities. Not only Docker, what happens is you have things like Kubernetes, then you have Mesos, then you have Swarm. These are the cluster solutions. These are Docker container managers, basically. Okay. Now, Kubernetes is from Google. Mesos is from Apache, and Docker, I mean Swarm, is from Docker itself. It's a native technology. Okay. So this is a very big technology. I mean, Docker to manage these things, but to give an idea, once you're comfortable with the Docker, you can deep dive into these things. Okay, any one of them you can just go and it can be very good. Okay, and once you have comfortable with Docker, the basic understanding of Docker, the best place to go is docs.docker.com, if I'm not wrong. Yes. So this is your, again, the way we have docs.chef.io. Similarly, we have docs.docker.com. This is actually your main documentation page for Docker for any of the information. So here you have all these, you can understand how it works. So Docker format, Docker, you have all these things. what is a Docker is. So for example, in here you can come installation on Mac, installation on Windows, on Linux distribution, and you have multiple options here, right? So you can come here, this you can check it out, docs.docker.com. I would highly recommend this to check it out, guys. And there are a couple of more things. Yeah, this should be the one. There are 2 or 3 videos provided by Docker, actually, which I think it should be here. Okay. Yeah, I think this is the one. So self-paced trainings, if you come here, you have 2 or 3 videos. 1, 2, 3 videos are there. So these are actually a very good point. Once you start with Docker, just go through the months. Each one is around 45 minutes long video. This also gives you a very good understanding of what Docker is all about and all those things. I have covered most of them, but it will be a very good refresher for you guys, and it covers a lot more, a lot of new things you might see in here. Okay. So it will take you kind of refresher for you to understand all the different functions.
Well, Chef is the champion.
Sorry?
I say Chef is the champion. All these are not that complicated. Chef is more complicated.
Yes. No, Docker is complicated, Karama. Docker is actually, I would say it's at par with Chef. Chef is, of course, it's a more comprehensive tool. See, all these other tools like Jenkins and Docker and Git and Vagrant, they are specific to a particular task, right? Whereas Chef is like end-to-end. It's complete DevOps tool, and that is why it is more complicated. But Docker is very, very, I mean, initial Docker, just fundamentals of Docker is easy to understand. But when you actually start working with Docker, and when you create microservices and all those things, when you work with developers to create microservices architecture with the help of a container, then it actually becomes very complicated. And that is a time when you need to understand, basics of programming, and how each service is talking to each other, a little bit of API also. So again, it's complicated. But that is no need to worry about those things now. Concentrate on the fundamental things. So once you work with the sites which I have created, and once you're comfortable with the basic things, just come here and make sure you read. I mean, you go through these 2, 3 videos. This will give you a very good information and very good foundation for Docker.
Yeah. So I want to ask you a question about Chef. Actually,
go ahead.
Like after registering for a hosted Chef server, yeah, and then you download the starter kit, do you have to download it on the workstation, like on your VirtualBox Ubuntu machine? Is that how you do it? Because I couldn't transfer the file because I downloaded on the Mac. So I couldn't transfer it from the Mac up to the virtual machine, but I know there is a way.
No, I think I showed you once how you can do it. If you remember.
Yes, I'll go back to the video. I will.
No, I'll show you right away. There's a very small thing. What you do is, on this place, see, this is the place where I have all my machines, right? Inside this Vagrant boxes. Right?
Yes.
Similar structure you also have. For each machine, you have one folder. Suppose I want to copy something onto my Docker. Okay, let me show you actually. In fact, I already have this starter kit. So let's say I want to copy this to my Docker machine, which I am accessing at the moment. I come here. You have this Vagrant file, right? In the same folder, you just paste it. Okay.
Yeah.
And now you come here and let's go to Vagrant. Now if you do an ls,
it was in, is it in Vagrant?
It was inside this one only, right? Which is the machine? Take Docker.
It was in Docker.
Yeah, it is in Docker. Yeah. Do I have a machine? Let me just check. Not this. GitLab one is also there, right? So, and okay, let's see. GitLab 1. Do we have anything? Wait, nothing is there at the moment. And if
No.
Vagrant. Okay, nothing is there, and I have the Vagrant file also, right? So what I'll do, I'll come back and copy, paste.
That's the starter kit, yeah?
That's a start. This is for my hosted environment.
Okay.
Similarly, you will also will have yours, right? So
Okay.
now if I do an ls, if you see here, now I have the starter kit.
Yes. So
And then
how do you
what?
How do you make all the machines communicate with the server online? How do you set the machines to the server? I wanted to ask you that question. How do the workstations, on your virtual box, how do they all communicate with the Chef server?
You just need to set up that thing. See, hosted chef, you need not worry because hosted chef is already has DNS entries and all those things are covered. So you just need to configure your workstation as per the steps provided for you, right? You just install, for example, I want to create this machine as my workstation. So I will install Chef DK on this machine, okay? For which I have given you the instructions already. Just go through them.
Yes. So the
And
workstation need to have Chef DK.
Chef DK and Chef starter.zip, which we just copied. So this you copy and unzip it to a location. When you unzip it, it will create the Chef repo file, right? Chef repo folder. That's all you
Yes,
need in order to
that's
communicate.
that's where I get lost.
Check it out again. Follow the steps. Make sure you first read that document which I have sent you for Chef Workstation. Just go through the document once. Essentially, these are the only 2 steps. You need to have the machine. Then you Chef DK, you download and install as per the
Yeah.
OS, Ubuntu or Red Hat, whichever it is. And then you download the Chef Starter Kit. That's all. Unzip it.
Okay.
And,
So the other machines, how do they communicate? I know about the workstation now. I completely understand that you have to download the Chef Starter Kit with the Chef.
I'll tell you, once you have the machine, this workstation ready, you have the command say knife node list, knife book list, and see if you are able to communicate. If you're getting results, that means your workstation is working fine. Right?
Okay, so how about the other?
Yeah. Once that is done, then you need to bootstrap the new nodes. See, we have a Chef server, we have Chef workstation, and we have Chef nodes. You install the server first. In our case, we are registering for the hosted Chef. It's again the same thing. Then you configure the workstation, and then you bootstrap the nodes. Okay.
Okay. So where do you actually bootstrap the nodes? From the workstation?
From the workstation, absolutely.
Okay. So that's clear.
Right.
Thank you very
and
much.
once you bootstrap the node, once the bootstrapping is complete, the nodes you will be able to see on your Chef server, like we have over here. It should be not in this one. Maybe in this one then. Yes, here it is. So once you bootstrap, see, right now we have, as part of our lab, we have bootstrapped these machines. So only these 3 machines are being shown. Right?
Yeah.
Right? See, Chef will be a little complicated.
That's more.
Yeah, just go through the videos once again. You have all the recordings, right? I'll just check if any recordings I have missed. I'll send those also, and go through them in sequence, and it should be absolutely fine. Okay, and make sure you practice from there. Learn.chef.
Yes, I understand.
Make sure you have practice. Once you have this setup ready, right? You have the workstation, you have the node, and you have the server. Then you make sure that you practice